Okay. So we can start today's session. So in the last class, we have been discussing about the ROS perception, right? We discussed about OpenCV, and interfacing of ROS. So if you just search with CV bridge, which is actually the core package, which is acting as a bridge between OpenCV and ROS. Okay, so I think we have discussed about this example already. Like um, the ROS is acting as a message passing framework. Like it can send and receive image data, and after receiving the image data, the OpenCV is going to process it. Okay, OpenCV is going to process it. So in order to process, it should be converted, or like it should be translated the ROS image message into OpenCV data type. Okay, and after processing, if you want to send the processed image to another node, it should be like converted again into ROS image messages. Okay, so that is actually the main duty of the CV bridge. Okay, so I hope that is clear to you. If you have any question, you can ask maybe in Discord something. Okay, so today's topic is a continuation of just a second. Um, okay, so today we will be discussing about PCL and ROS interface. Okay, so I hope you all remember about the point cloud library, which is mainly for processing the point cloud data, 3D point cloud data. So let's directly go to the interfacing of PCL library and ROS. Okay, it's almost similar to OpenCV. Just a second. Okay, so this is a point cloud library. I think you all are aware of this library, and so if you simply search for PCL ROS interface in Google, okay, PCL ROS tutorial or something, you're gonna get the tutorials of PCL and ROS directly. Okay, so this is one tutorial, and you can also see a package called PCL ROS. Okay, so I can share the link of that. Just a second. You can take it. So this is actually acting as the bridge between PCL and ROS. Okay, so the thing is very similar to OpenCV. So what was the main input for image processing? It's a 2D image, right? It's a 2D image, but here it's 3D point cloud, and the point cloud library is coming up with some APIs. Okay, like for filtering, for object detection, or like to read each points from the point cloud. So there are many APIs in the point cloud library. So this PCL ROS bridge, okay, PCL ROS bridge, it's actually a library which can convert ROS point cloud to message to the PCL data type, and PCL data type into ROS point cloud to message. So it's very similar to the OpenCV. Okay, so maybe I can explain it with some examples, so it will be clear to you. So there is a basic example for publishing and subscribing, publishing and subscribing of point cloud. So that is the best example that you can take. Yeah, so that is and there are some existing tools available like convert. Yeah, that I will discuss. So we can directly go to the examples, okay, and we can discuss. I think that will be good. So I have actually prepared a package. I think it's already there in my book or something. So there is a package called PCL ROS tutorial. Okay, I think you may get it from Gate, but yeah, so similar to the CV bridge package, in this PCL ROS tutorial, you can first check the package.xml. So the dependencies are PCL ROS. Okay, so that is the main dependency. Okay, which is the core package. Okay, so that core package is bridging between ROS PCL message and PCL data type. Okay, so when you create a package for yourself, just add these dependencies. Okay, so for building this package, you need the PCL ROS, which is a mandatory dependency, and also you are going to send the PCL data, right, which is in the sensor messages. So if you check for sensor messages, point cloud 2, which is the PCL ROS message. Okay, so this is the ROS message type for PCL. Okay, so you have to convert the point cloud data type to ROS PCL message type and vice versa. Okay, so let's get into the code. So I hope the package.xml is clear to you. Only thing is the PCL ROS package you have to add, and in the CMake list, it's almost the same. Like you can check the minimum version, then the project and the dependency packages, and like in order to compile and build a C++ program, the same thing, like add executable and target link libraries. Okay, so you can simply do this. For OpenCV, I think we have add the fine package OpenCV. Maybe I can take that as well, so you will get a comparison. CV bridge tutorial CMake list. So this was for the OpenCV this is for the OpenCV. So you have included the OpenCV include directory, and for the linking you have include OpenCV libraries. But for PCL you don't need to add anything. Okay, it's very easy. Like just include the find packages. You can include PCL ROS, which is a main dependency, and send a message, and just compile your C++ like this. Okay, so this is the configuration. So if you create any package, just make sure you are with this configuration. Okay, I will be like adding these code to the GitHub, so you can check it. Okay, so now coming back to the application, PCL ROS application. So maybe first I can try with a publisher, PCL publisher. Okay, so I think you already done the string hello world and all, right? So here we are going to see how to create a point cloud using point cloud library and publish that point cloud data. Okay, just a second guys. So let's see the code first. Okay, let's see the code. Okay, so just check this code. I think it will be familiar to you, like in order to create a publisher, I think you already know, right? You have to create a node handle, then you have to create a publisher like this, right? So instead of string, you have to use the sensor message point cloud 2. Okay, so that is the main difference. And in order to include this message, you have to include the header file, that is sensor message point cloud 2. Okay, and what is happening here is that we are actually creating a point cloud data using PCL. Okay, so in the introductory class, I have discussed about the kind of data types available in point cloud, but I can give an idea for this example. So here you can see this line, right? Maybe I can increase the font size a bit. Just a second. In the preference, let me, yeah. So this line is actually creating a new variable or new object for holding the 3D point cloud. Okay, it is very similar to int a. I mean, you can just compare like int a. What int a does is that a is an integer. Okay, similar to that, here this is actually a class and cloud is an object. So this class can hold the point cloud data. Okay, and this is actually specifically say it's a template class. I'm not sure you heard about template class, but the template class is that in order to change the type of point cloud, there are different kinds of point cloud. There is point cloud without RGB data, with RGB data. So RGB data means it can hold a pixel in each point. Okay, like you can see depth sensor point cloud. So if you check the depth sensor point cloud, you can see there is an RGB data that you can add to the point cloud. This is actually a point cloud on the right side. Okay, but in order to store that point cloud, it needs more field. Okay, so the point cloud is a collection of points, right? And each point having an information. What is the information? The XYZ data. Okay, and along with the XYZ data, it can hold more fields, like it can hold intensity, it can hold RGB value. Okay, so currently we are going to create a point cloud with only the XYZ value. Okay, so for the intensity or for the RGB, there is nothing. Okay, nothing. It's our choice. Like we can create a point cloud which is only having the XYZ value. So if you want to create an point, just give the XYZ value. Okay, then you will get a point, something like that. So this is a cloud object, and this is the ROS message to hold a point cloud. Okay, so now don't worry about this loop and all, but the idea is we are creating a cloud data. Okay, we are actually populating this cloud object with some points, with some random points. Okay, with some random points. So inside this cloud data, there is a field called points, width, height, all these things we can set, and then like after doing this step, we are literally filling the point cloud data. Okay, so after this step, your point cloud called cloud object is having some data. Okay, then here what we are doing is we are converting the cloud object to what? To the ROS message. So that is what the main step here. So this is the bridging API, or the API which is converting the PCL data type into ROS message. Okay, so if you convert to ROS message, then we can simply publish it. Okay, you can simply publish it. So here on the output, you are getting the converted point cloud message, ROS message. And then what happening is that in a while loop, okay, while loop at a rate of 1, okay, in each second it will be publishing this point cloud. Okay, so for publishing, in this example, they are simply using the publish subscribe. There is no optimization, simply showing like how to send a point cloud through a topic. Okay, so in this loop, after creating the cloud, we are publishing the cloud. So that is what happening. Okay, so let me run this node first, so you will get a clarity. Okay, so in order to run the node, I think you know how to, like, first you have to start the ROS code. Okay, and what was the node name? Like the PCL publisher, right? So just check the CMake list for getting the executable name. So PCL publisher node, that is a executable name. So just run the PCL publisher node. So the package name is PCL ROS tutorial. Now PCL publisher now. Okay, so just run it. So it seems like working. Okay, I already built this package. Okay, this workspace now, the workspace called CatKing workspace, I already built. Okay, so after creating your own package, you have to build it and check for errors if there is any. Okay, so it is running, right? So now, yeah,
Which protocol it is using actually here?
here it's simply using the publisher subscriber. Yeah, that is.
Yeah, backend is it means HTTPS or it is what kind of protocol for pushing the data?
Yeah, so that is actually the underlying communication protocol called TCP ROS. I mean, it's actually TCP IP communication, but is like customized for ROS. Like ROS one is
Okay.
actually using the TCP IP base. Sometime it is using UDP, that is for ROS two. And there is another thing called XML. I think RPC. So if you search for XML RPC, it is using in ROS. So this is actually the heart of ROS 1, and this is actually
Okay.
changing in ROS 2. It is replacing in using DDS. That is a major change. So yeah, yeah. So uh,
I mean to say in IoT we have a different kind of protocols like HTTPS and another there is one more protocol which is used to same subscribe publish protocols.
I think you are
That's the
talking about the
reason.
MQTT, or yeah,
Yeah,
okay, yeah,
MQTT. Yes,
yeah, yeah.
yes,
So
yeah, yes.
similar to that, in ROS there is a pub sub communication that is
Yeah.
actually using TCP socket based
Yeah,
communication.
down the line everything is TCP and UDP,
Yeah.
but I mean to say which whether it is HTTPS or MQTT.
No, not
Just
MQTT.
I wanted to.
MQTT is completely different. In ROS, it's not.
Yeah.
Yeah, it's a separate thing. But in ROS, we are not using that.
Okay, so it has its own protocol for
Yes,
it. Yeah,
yes,
yeah,
yes,
yeah. I understand. Okay,
yes.
okay, understand. Thanks. Yeah.
So yeah, so using the PubSub, we are sending the point cloud, and yeah. So currently, I think it is running it, and so we can simply check the topics using ROS topic list, and then you can find the PCL output. That is the topic that is publishing, right? So using the ROS command line tools, you can check different thing like what is the bandwidth of the data that is publishing. So if you just check the bandwidth, you can check the bandwidth is like 1.78 MB. Okay, because it's publishing a point cloud which doesn't have much. It's not using bigger bandwidth, but I think it's a very small point cloud. That's why. Otherwise, it will be using like 10 MB, 12, more than that. Okay, and also we can check the hertz rate of publishing. It seems like 1. So like you can check it is publishing at a rate of 1. Okay, and like it's a sensor data, right? So you can actually visualize this sensor data using RVs. So just take RVs, and then you can visualize using RVs. Yes, yeah, I have seen Tejas, yeah, your comment. So thing that you have to note is that for publishing, we are using the sensor messages point cloud 2, right? So if you take the sensor message point cloud 2, uh, one of the mandatory thing that we have to fill is the header. Okay, header. So you have to give the header frame. Okay, so that is what here it is doing, like output dot header dot frame id. Header is again a ROS message. So inside that there is thing called frame id, and we are giving the frame id, frame of reference. The frame id is called point cloud. Okay, so why it is important? Because in RVs we have to give the fixed frame as point cloud. Okay, the frame id, and then you can add the topic, and you can able to visualize. This is the random point cloud that is publishing by the node. Okay, it's like it's a cube. Okay, and it doesn't have any data, like it's simply some points, and you can style it in the sense you can select its color transformation. If you choose axis color in ROS, it will be visualizing like this, like it is using the axis color like red, green, blue. Okay, and you can simply change it, flat color and intensity. Yeah, so but these information are not storing in the point cloud, it's just the transformer. So RVC is doing that. Okay, so this is the point cloud that is publishing by the node. So what is the problem? What is the problem with this kind of pub sub for the point cloud data? I think I have already mentioned. Okay, I think Tejas is having a question. What is a color signifying? So I think Tejas, I mentioned that color is not from the point cloud, but it is actually doing by the RVs. Okay, the RVs is actually doing that because RVs is doing an additional processing. Like if you add the point cloud and if you change the color transform, then you will get the color only in the visualization. Okay, only in the visualization you can view the color like this. Okay, but the point doesn't carry any color. Okay, and these are like the colors of the axis, red, green and blue. Okay, so that is only the significance. Okay, yes. I hope that is clear to you. And yeah, so the main problem with this kind of communication is it will take a lot of bandwidth, like the image. Okay, there is another question. Okay, if we have the actual depth data, still color doesn't mean anything. Okay, if we have the actual depth data, still color. No, like Tejas, what happening is that we can incorporate the RGB value to each points if we want. Okay, yeah. So like there is color transformer. Yeah, like closer is a different color, and for yeah, so that's what, like there is actually color transformer available. Okay, so if we have a point cloud and if we apply some transformer, then you can visualize like that. But the thing is that the point cloud doesn't carry any data. Some point cloud may carry intensity value, like based on the closeness of the object, that intensity can differ. So if you visualize that point cloud, you will get the intensity like that. But if you are like publishing a plain point cloud in the sense it doesn't have any color transform, then we will only get the the raw point cloud, and we can like do the color transform. So it depends on the point cloud that we get. So there are different kinds of point clouds available. There is point XYZ, then point XYZI, which is having intensity, then point XYZ RGB, and I think there is point. So if you check for this, like just search, and you will get different kinds of point cloud. Just a second, I can show you a point XYZ. Okay, let me check. XYZI. Yeah, point XYZI, and there is these are some of the commonly using. Yeah, see, point XYZ RGBA and RGBI. RGB. Okay, all these things are available. So depending on the kind of point cloud that we are using, you will get the visualization. Okay, so that is clear. Now just a sec. Okay, so back to the code. So it is not advisable to send the point cloud through the topics because of the bandwidth constraint. But you can do that anyway. You can do, but it is not advisable. Anyway, we can jump to the next example, and I can also show you the best method that we can use for working with point clouds and image. It's called nodelets, but I'm actually mentioning that in a separate chapter, but I can simply give an idea. ROS nodelets. Okay, so ROS nodelets is it's a kind of node, I will say. It's a different kind of node. Okay, but the advantage of this is that it is not transporting anything. For example, you created two nodelets. Okay, you created two nodelets, and if we communicate, I mean, if these nodes are communicating, then there is no transportation cost is coming. Like if there is a publisher and subscriber, normal publisher and subscriber, and if they are communicating, then there is a bandwidth constraint, right? But if these nodelets are communicating, zero bandwidth. So it is using another technique. It is actually using shared memory architecture. So there is zero memory, zero copy transport between the algorithms. So this method is using for this high-end programs, like for PCL processing and image processing. We are using the nodelets. It's similar to plugins, very similar to plugins. And in ROS 2, everything is considered as nodelet. So we don't need to separately code it as nodelets. Everything is considered as nodelet. Okay, nodelet like structure. Yeah. So yeah, so that's it. And let me take the code again. So we have seen the PCL publisher, right? Now we can see a PCL filter. Okay, PCL filter. Just a second. Okay, so there is a question from Tejas. Is it like we are making our code as library by coding as no? We are making our code as a library by coding. The question is not very clear. Yeah, so one thing I understood was like we can create our own library. Tejas, like for example, if you want to share some functions to me, for example, okay, that you created some functions and you can share it. Maybe you can share it to the public. So you can make it like a library. Okay, so I can build in my PC and I can use your functions. Yeah, I can access it like that. So I can include your library in the CMake list. So CMake list will read your library, and I can use your library in the CPP file. Okay, so all these library like the PCL, OpenCV, all these are library written by developers, and we are simply including that library in our project and reusing that function. So we are not doing the reinventing of wheel. Okay, I think that is what you meant. If not, you can comment. Okay, so okay, so there is another question from Kalpesh. Can you please shed some light on the PubSub model for point cloud? Yeah, Kalpesh, there is no difference. There is no difference like for the publisher. No, the publisher and subscriber that I shown is the same as the talker and listener. There is no difference. Okay, but the difference is actually in the nodelet. Okay, which is another topic. Okay, so here like if we check the PubSub of the point cloud, it's the same. Like instead of string, in the Docker we are using the point cloud too. That's it. Okay, and yeah, here what we are doing is we are simply publishing it. Okay, and the next code we are seeing how to subscribe it. Okay, how to subscribe it. Let me see whether it's a subscriber or not. Yeah, it is involving subscribing. Okay, um yeah, just a second. Yeah, so if you have doubts, you can comment. Okay, so in this code we are going to see a subscriber of a point cloud, um, and after subscribing the point cloud we are doing a filtering. In the image processing, in the OpenCV session, we have seen the edge detection, right? ROS, OpenCV, edge detection. So here we are seeing a filter, okay, a downsampling filter. Okay, so there is a question from Kalpesh. I remember you mentioning about the problem with the PubSub. Yeah. So that's what, Kalpesh. So the PubSub is not good for big like data, like image or um, point cloud. So in order to solve that, we have to go with the point cloud. Okay, so it's not for all the application. Okay, it's not for all the application. If you are working with a simple application with simple small images or something, that is okay. This simple method PubSub will be okay. But if you are working with real-time data, for example, you are reading from a depth sensor and you are reading the entire point cloud and you have to do some object detection. So just think you are like publishing a big chunk of point cloud, and you are subscribing to it, you are processing to it. Okay, so much computation will be wasted for serializing and deserializing of point cloud. Okay, so we can avoid that. We can save bandwidth. So the solution is nodelets. Okay, nodelets is actually like a plugin. Okay, what it does is that it is actually internally, these nodelets are communicating through shared memory architecture. So if one node is a nodelet is sending some data, it's not actually using the bandwidth. Instead, it's actually sharing the address of the memory. So there is no need to no need to send it. So for example, there is a nodelet 1 and there is a nodelet 2, and nodelet 1 is sending some data, meaning it's actually sharing the address of the data to nodelet 2. Okay, so nodelet 2 will receive the memory location and it will read. So there is no need of sending it or using the TCP/IP internal communication protocol. So yeah, so if that is clear, let me know. Yeah, okay, Kalpesh. So yes, so coming back to the code for subscriber and processing, you can compare this code with the edge detection code that we have already done with this OpenCV. So here what happening is that the code is subscribing to the point cloud, okay, which is publishing by this node. Okay, this node is publishing a point cloud, right, which is actually subscribing by this code. Okay, and not only simple subscribing, it's actually doing some processing on it. Okay, the processing is using the point cloud API, point cloud library API. So here also we need that conversion, right? We got the point cloud message from ROS. We have to convert to point cloud data type of PCL, and then we have to do the filtering, and then after doing the filtering we have to again convert that processed point cloud to ROS message, then publish it. Okay, so maybe I can show you the example, the working, and then we will discuss it. Okay, so in order to run this, we have to publish that point cloud first, right? So I'm publishing it, the old node that we have used for publishing, we are publishing it, and now we are subscribing to it. So which is the node? It is PCL filter, right? So ROS run PCL tutorial, which is again, yeah, just a second. Sometime if the auto completion is not working, you can just do the ROS CD. So make sure you are switching into that package, and then if you try, the auto completion may work. PCL ROS tutorial, then PCL filter. Okay, so do you want to see the, so currently there is a publisher and subscriber. Do you want to see the RQT graph? We can simply see the RQT graph, right? What is happening in the background? So this is actually happening, very similar to talker and listener. The PCL create node, okay, that is a publisher node, is publishing a topic called PCL output, and PCL filter node is subscribing to it. Okay, and now we can start the RVs. Okay, and let's visualize the actual point cloud. So just use the header frame, fixed frame is this, and first visualize the filter data. Okay, so I'm just giving the color transformer as axis color, and just increasing the pixel size or the point size. So these all are doing by the RVs. There is I mean, the data that we got from the node is actually doing processing by RVs. So this is the filtered data. Okay, so now we can see the actual data, point cloud data. So this is actual data. So just a sec, axis colors. Okay, just switch. This is the actual data. Okay, so this is actual data, and this is the filtered data. So you can see the difference, right? What is the main difference that you have seen? It's actually downsampled. The density is actually reduced, right? So if you get some point cloud, and if you want to like make the point cloud lighter, okay, if you want to do something like that, then you can use the filter that we have used in this code. Okay, and there are many functions that we can do. This is a demonstration of the PCL API function. Okay, so now we can check the RQT graph again. So here what is happening is that the PCL create node is publishing PCL output topic, and PCL output is subscribing by PCL filter node, and after processing, after filtering, it is publishing to a topic called PCL filter. So if you check the ROS computation graph, it looks very simple, right? So that's it. I mean, the communication is very simple, and yeah, so that's what we have to say about like these application. Okay, so I'm just stopping the application and coming back to the code. Okay, I think you got an idea what is going on, and just discuss the code. Okay, just we are going to discuss the code first. So here in the subscriber code, in order to get some flexibility, we have used a class, okay, class to subscribe, okay, and class to, I mean, the same class for publishing the processed point cloud and also doing some processing. Okay, so the class is having everything. So if you check the main code, you can see we are creating an object of this class called cloud handler, and we are doing the ROS pin. So the code will be waiting here for the topic. Okay, so that's how the subscriber work, right? So when we initialize this class, this is the constructor. So when we initialize, when this line happen, the constructor will be working, and in the constructor what happening is that the constructor, this line is waiting for this topic called PCL output. Okay, and whenever we get some point cloud data in the PCL output, it will be calling which function? Cloud CB. Okay, so I actually shown to you this notation, this usage, like this is how we are like pointing a callback inside a class. This is very important, guys, because you are going to use that in your application. Like if you create a big project, not only big project, if you are working on any project, you may be using C++ class, and this is how we are pointing a callback inside the class. And this is a callback, guys. This is a callback, and this is for publishing the filter data. And whenever a data comes, this callback, this function will be called. Okay, and inside the callback, what we are doing is we are addressing the point cloud using we are addressing the point cloud using the pointer. We are not creating a copy of the received point cloud. So we got the point cloud here, point cloud address here. Then what we are doing is we are converting the received point cloud to what? To PCL data type. Okay, then only we can do the filtering. Okay, then only we can do the filtering. So in order to convert the ROS message, ROS PCL message to PCL, actual PCL, we can use from ROS message. Okay, from ROS message. So the input of this function is the input point cloud, I mean point cloud ROS message, and output will be the point cloud data type. Okay, so the converted point cloud will be stored here. Okay, so we got the point cloud data type, and the point cloud is storing in the cloud object. Okay, now we have to process using this cloud object, right? We have to process. So in PCL library, there are a set of functions to do processing, like filtering, segmentation, all this stuff. So we are using, for demonstration, we are using a function called voxel grid, which is, voxel grid means like it is for downsampling. Okay, downsampling. So we are creating an object of the voxel grid, and inside the voxel grid object, you can able to set the input point cloud. Okay, so this is what like the intention, like we are setting the point cloud to the voxel grid filter basically. So after setting the input, we can just set the filter like attributes. Okay, so these are some filter attributes, and then this function does the filtering. Okay, and after filtering, the filter data will be storing to cloud filtered. Okay, this is another object. Okay, you can see like there is two objects. One is for storing input and one is for storing output. Okay, so this cloud filtered, no, the cloud filtered will be storing the filtered point cloud, and after that we can able to convert that filtered image into ROS message. So that is what happening here. Okay, so from ROS message is converting ROS message to PCL data type. To ROS message will do the conversion from PCL data type to ROS message. Okay, so don't confuse with it. So this is output cloud filtered, and we are storing the converted ROS message to output. Output is here. Okay, so we have converted. Now what? Now we have to publish it, right? So whenever we subscribe to anything, it should be converted to it should be converted to point cloud data type, then do the filtering, then again convert to ROS message, and then publish. Okay, so the logic is very simple, but we actually done using the class method. That's it. That is only the difference. So let me know if you have any question to I mean for this application. It's very simple. The only intention is to like demonstrate how the subscriber, publisher, and the bridge works. That is the main intention. Okay, so how the bridge works, that is what the main intention of this session. Okay, so is that clear, guys? If this is clear, then we can jump into the next topic, which is the object detection, YOLO, which is somewhat interesting. YOLO, ROS interface, and ROS and 3D object detection. I didn't have any like example for 3D object detection, just from repository, but I think I have set up the YOLO ROS interface in my VM, so I can demonstrate that. Yeah, so let me know if you have any question, guys. It's a very simple thing, like for the PCL is mainly the publisher, subscriber, and the bridge. Okay, so Kalpesh is having a question. The filter part is not clear. I can discuss that. Yeah, so Kalpesh, so the PCL, I think you already know the PCL is a library, right? So inside that there is a function called voxel grid. Okay, so the objective of the filter is to reduce the size of the point cloud or downsample the point cloud. So if you have a dense point cloud, I think you have seen the input point cloud, right? You have to reduce the number of points. Okay, you have to reduce the number of points. So what we are doing is we are creating a voxel grid filter inside the point cloud library. Inside the point cloud library there is a voxel grid. So just search for voxel grid if in Google, so you will get the correct documentation. So this is the class called PCL voxel grid. Okay, and inside that there are many functions like set leaf size, then filter. I mean, these all are the functions inside this class. So what we are doing is we are creating an object of this filter. Okay, this is a class, basically template class. Vox object is an object. Okay, and inside this object there are many functions, right? These are the functions inside this class. Okay, so you can call this class call these functions. So first function is set input cloud, so which is basically setting the input to the filter. Okay, in order to filter there is some, we need some data, right? So this is the function that is setting the input. Okay, after setting the input we can set some filter attributes. Okay, so that is what this function does. So that function you can find it from this list. See, set leaf size. Okay, so the attributes like point one, I think it's actually in XYZ axis. Okay, so just understand that this is actually some attributes of the filter. Okay, now this is what the final function, which is doing the actual filtering and storing the filtering on another variable or another object. Okay, so this is what the filtering part does. So we set the input, we got the output here, and then we are converting the filtered output to the ROS message. Okay, so is that clear, Kalpesh? Okay, okay, great. So now I think if that is clear, guys, we can jump into the next topic, which is object detection. Okay, ROS and object detection. So this is very useful topic. Okay, a very useful topic, and we are going to discuss the 2D and 3D object detection. So basically, if you are working with some kind of pick and place or some kind of mainly the object detection is useful in pick and place, and another big application is the self-driving cars. So if in the self-driving car software, you know, like there is many cameras and there is lidars as well, right? So the object detection can be done in 3D and 2D. So if you have the lidar data, you can do the 3D object detection, and if you have image data, you have to do the 2D object detection, and sometime we can do both together. Like we will be getting the 3D data and the 2D data, 2D detection data at the same time, and you can actually like mark the object in 3D as well. I think in ROS and 3D object detection, I think we are actually seeing that. So now directly into the YOLO object detection. It's very famous. I think you maybe heard about the YOLO object detection. If you're not, like, just search for YOLO object detection. You will get, I mean, multiple tutorial. So this is the official website. Okay. You only look once. Basically, it's a research project. Okay, YOLO is a very popular research project, and I think I have created a blog post in Robo Academy website, I think. Yeah, a gentle introduction to, maybe I can share that. This is a good introduction to YOLO. Basically, yeah, so there is a research paper for YOLO. I think I have, yeah. This guy created YOLO object detection, and after some version, I think he actually stopped the project because I mean, what he said was this object detection is using for some good project, but also for some bad, I mean, use cases. So he just quit from. Yeah, this was the Twitter post that he posted. See, I love the work, but the military application and the privacy concern eventually become impossible to ignore. So because of these things, because of the ethical concern, he actually stopped the project in 2020. Okay, but a lot of open source developers continued with YOLO. So I think after that the YOLO v4 came. Okay, so it's a successor of YOLO v3. So there are, I think YOLO v7 is the latest. So there are a lot of modification happening in the object detection and also YOLO object detection, and also a lot of optimization. It is getting faster. Okay, yeah, I think v7 is the latest. Okay, so Yeah, so the question is what is YOLO and why we specifically use YOLO for this chapter. Maybe I can discuss that with this website. So YOLO is actually an object detector. It's not like the CNN based object detection and all. It is using a different model and different framework. This author actually created another framework called Darknet. Okay, Darknet, and which is having a different architecture. Okay, and the advantage of this architecture is it's very fast. Okay, it's very fast, and even we can do the object detection in real time. Okay, so that's why it's went so popular. And then uh, if any libraries getting popular, I think there will be a ROS wrapper around it. Okay, so what the ROS wrapper does is that the ROS wrapper will read the image from the camera. I mean, if you are publishing an image from uh, ca- uh, 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 the camera driver, it will be subscribing to it and do the object detection, and then it will be visualizing and publishing the object detected information. Okay, maybe I can first show um, the demo, and after that I can explain so you will get a clarity. So first thing what I'm trying to do is I need an input image for the object detection, right? So you know the ROS launch USB cam. USB cam is the driver package for USB based webcam. So once we start this launch file, you know what happened, right? It will be starting the USB cam node and then publish the camera images. So I'm starting it, and you can see me here. So I'm just minimizing it, and you can check the topic list. So you can see this is the raw image. Okay, this is a raw image that is publishing by the driver. So now we can start the YOLO object detector. Darknet ROS. Okay, Darknet ROS. Yes. Okay. So it is starting, and then it is waiting for the image. Okay, so it is waiting for the input image. So we can check. So our input image is USB cam image raw. Okay, and what Darknet expecting is the input image is camera RGB image raw. We can change that inside the code, but currently I'm planning to do a quick fix for this. Okay, so the input image that we publishing or the camera driver is publishing is USB cam image, USB cam image raw, and the Darknet node, right? This node is actually subscribing to this topic. Okay, so what we can do is we can do a quick fix. Like there is a node called topic tools. Topic tools, this is just for the demonstration. Okay, topic tool relay. After doing this, maybe I can explain. Maybe you can understand what is happening. So what we are doing is we are just relaying this topic to this topic. Okay, I think it is similar to the what in the launch file we have been using a command for like redirecting. Okay, so the relay is like a redirection. The USB cam image raw is getting publish us this topic. Okay, so if you do that, as Tejas mentioned, it's a remapping in the launch file. So similar to that, this is a kind of remapping. Okay, so this topic is publishing as this name. Okay, and now you can see it started detection. See, the detection will be very slower because I'm currently running in a VM, and so you can see the backpack is detecting, the person is detecting, and my mic is actually detecting a sport ball. Okay, so that can happen, and let me show my mobile phone. Oh, I have a car even. Yeah, you can see it's a cell phone that is detecting properly. And let me show the AC remote. Just a second. Oh, it's detecting a cell phone itself. Okay, okay, and let me show my water bottle. Okay, yeah, it's detecting as bottle. And now uh, what about this? I have an Android board. It's detecting as cell phone. Okay, and I have a Tivasi launchpad. Sorry. Uh, that's not even detecting. Yeah. So guys, I think you got an idea, right? Like it can detect various object that it is trained for. Okay, but there is false positive. There is, I mean, you can get this kind of detection in almost all detection framework, but we can optimize it to reduce the error anyway. So what happening is that the the detection that we have seen is actually using a framework called darknet. Okay, which is darknet, I think it's already mentioned, it's an open source neural network framework. Okay, neural networks framework, and that is not the important stuff. It's actually written using C and CUDA, so that is the important one. Okay, so I think you know about the CUDA, right? So the CUDA is for GPU computing. Okay, so if you have a GPU, specifically NVIDIA GPU, uh, this darknet framework can make use of the CUDA. Okay, so it can make use of the GPU, and then the computation will be very fast because the GPU computing, it is having multiple cores. But if you only have CPU, then it will be like using maybe the C APIs. Okay, currently I have shown the CPU support. Okay, CPU support, I think you have seen its limitation. The frame rate is slow. It's like 2-3 fps. But if you have a good GPU, or if you are running in Jetson Nano or Jetson Orin or Jetson Savior, you will get the CUDA cores and it will be very fast. Okay, so the implementation of this neural network framework is actually done in C and CUDA, so that's why a lot of people are preferring it. And the architecture of the network is also very optimized, I think. Okay, the method, the algorithm also is very good. So there is a comparison for, I mean, different versions of YOLO. So it seems like they have, yeah, so the YOLO v7 is the latest one. Okay, so um, the darknet is the framework. Okay, and um, there are already trained models available, and you can also retrain it. Okay, so the instructions are already there in the framework, and you can even work with Python, C++, C. Like if you want to work with object detection, only object detection, then you can work in C++ or Python. Okay, for the detection part. But if you want to work with the ROS system, one of the framework, there are many repositories. One of the package that I have seen is the darknet ROS, but it seems like it is working with YOLO v3, which is somewhat old, okay, but it still work. I have shown the demonstration of this package only. It is not supporting YOLO v4, it's only supporting v3, okay, but this node is somewhat stable, okay. So yeah, and YOLO v7 is the latest one, and it seems like the YOLO v7 is somewhat faster. That is actually what we want in most of the detector. We want more faster framework, right? So here you can see yeah, comparison. YOLO v3 is here, and YOLO v7. I think they are actually saying about some metrics. I'm not very familiar, but it seems like YOLO v7 is much better. Okay, so that is only thing we need to think about. Yeah, it's much faster means faster FPS. I mean higher FPS. Okay, and the YOLO v7 base paper is also mentioned. Yeah, so it seems like 5 FPS to 160 FPS, which is actually good, but the accuracy is not that good, it seems. Okay, anyway, yeah, so that is the darknet framework and darknet ROS framework. Okay, so you can simply set this up. There is not much hurdle to set this up, but currently they have included this thing. Yeah, so you need some hack to do it. Not hack, but yeah, maybe I can show you how to install these darknet ROS repository. So first, what you have to do is there is an option to add SSH keys, and then you can execute these commands to build it. But if you are too lazy to set up the SSH key, then what you can do is just click here. Okay, so this is the base library, that is the darknet. Okay, just click here, and yeah, first maybe what you can do is you can clone this repository, okay, to your Catkin workspace. Okay, just a second. So I have cloned the darknet to where? Just a second. I think it's in another workspace. Learned ROS workspace. Yes, and now this is the darknet ROS repository. Okay, what you have to do is if you when you clone, you will get folders like this. Okay, but you will not get files inside the darknet actually when you cloned initially. Then what you have to do is just clone the darknet library, and maybe you can copy the files to this folder. Okay, then that will work. Okay, so that's what I have done. So yeah, it's actually a quick hack for lazy people. Instead of setting the SSH, so then you can do the Catkin make. So like after setting the darknet, just do the Catkin make, so you can able to see it's building properly. Maybe yeah, so that's it. Okay, and when you do the Catkin make, it will be automatically downloading the weights. Okay, like it is downloading YOLO v2, v2 tiny, and YOLO v3. Okay, so that is already doing by default. So when you run the object detection, it will be automatically start detecting using the trained models. Okay, so it's just like there is nothing to explain. Like there is a project called darknet ROS. You can simply set this package in your workspace, and then yeah, you can able to do the object detection. So there is nothing with OpenCV PCL. I mean, you don't need to worry about it. If you need some object detection, ready-made object detection, I think YOLO is one among them. Okay, but it is actually depending on OpenCV boost and all, but you don't need to care about these things. Okay, and if you need to like retrain or something, then I think you have to do some process. Okay, I think that they also mentioned that. Okay, yeah, pre-trained, yeah, there is some instructions, but the YOLO will be working good in Jetson series or like NVIDIA GPU. But if you are working with CPU, then it will not give much FPS. Okay, yes, and if you search for like YOLO 3D, you will get another repository, which is actually the combination of YOLO and the 3D object detection. So I didn't try this package before. This is not a ROS project, guys. It's actually like the basic YOLO model for object detection in 3D. That is a project saying. I didn't try this yet, but this can be used for working with Velodyne point cloud and object detection. Okay, so if you have a camera and Velodyne, then you can use this repository for working with 3D object detection. Okay, I'm not sure about the accuracy, but yeah, seems like it is providing a good estimate of the object. Yeah. Oh, YOLO 4D. Okay, so you can try this if you are interested. Seems like somewhat old project, but this is one of the project actually. Okay, there are many YOLO 3D repositories available. So yeah, I think this is a quite new one, it seems. Yeah, this is comparatively good, I guess. Can also check this. So it's specifically for like the self-driving cars, that is actually mentioned, and they seems to be using YOLO V5. Okay, that is good. Okay, they have a Docker file as well, so we can simply like pull the Docker and run. Okay, that is the best way to try. And they also mention how to train the data set. So it seems like very good project, guys. I think it can be used for autonomous driving. Yeah, autonomous driving. There is a GitHub yeah, post as well there. That is good. Yeah, I think this project may be useful, guys, if you are working with self-driving area. Okay, yes, okay, so that's it. I think we can conclude today's session, and tomorrow I think we will be starting with the next chapter, that is ROS and embedded system programming. So there are many things that is included, so I will give you an idea about all these things. So we will be first discussing about the ROS serial Arduino, then we will be seeing the Jetson Nano Raspberry Pi things. Okay, how to set up Jetson Nano Raspberry Pi and set up ROS on it. Okay, okay guys, thanks for attending. See you tomorrow. Okay, if you have any question, you can ask now. Okay, time for question, guys. So let me know if you have any question. Yes,
Yeah, same
yeah,
time,
same time.
same time. To, okay. Because I was thinking 6 o'clock, so here,
Yeah, okay,
European time.
okay, okay. So any question, guys? Okay, so if you don't have any questions, I think we can conclude. Tomorrow we will be discussing the ROS embedded. Okay, the objective is like give an idea, like when you start working on the robot, mostly you need to work with some embedded system. So like it can be maybe a simple Arduino, or it can be a customized board. Some people will do like customized Arduino board or Raspberry Pi, anything. So how to set up ROS on a single board computer, how to set up or how to work with ROS and microcontroller board, all these things that we can discuss tomorrow. Okay. uh, yes. Yeah, Rohan. So regarding the project list, again, I am due. I couldn't. So let me try to send this week, Rohan. Sorry for that. Anyway, like the thing is that I came from vacation September 14th, and I got a lot of queries for the projects, and also I am actually settled with all these things now. And next month itself I'm starting new project, and yeah, so the list I think I can work on this week for sure. Okay. Okay, guys. Yeah. uh, Thanks again. So see you tomorrow, same time. Bye everyone.